Hello, and welcome to this lesson on special types of linear systems of equations. So we're still talking about systems of equations, which was two or more equations with the same variables that we solved in the last lesson by graphing. And we found where the two lines intersected. So if you imagine I had two lines, that point of intersection was the solution. And we would say it was like 3 comma -8. Where the 3 was our x variable and the -8 was our y. So that was what we did in the previous lesson. In this lesson, we're doing more of that, but we're going to see what other sorts of things can happen. So the essential question says, how do I find the solution to special types of linear systems? Did you know that if you have two straight lines, imagine like really long pieces of yarn or two yardsticks, there's actually 4 different ways that these two things can be oriented. You can lay them on a table and you can make them parallel. So like the first example I have here, these two are parallel. They have the same slope, they're going in the same direction, they're parallel. You can make the two pieces of yarn cross over each other, like so. So these are intersecting. You could lay the yarn on top of each other, so it's essentially just the same thing, like the same line. That's called overlapping, and so this is kind of what it looks like. Lastly, if you pick them up off the desk or off the table and hold them so they're not parallel or overlapping or intersecting, they're called skew. So if you imagine here, this line here, this bottom edge of this rectangular prism, and this other top corner here, these two lines in a flat screen, like on the screen you see now, it looks like they're going to crisscross, like if they would extend this green line, it'd crisscross. But in a three-dimensional space, it wouldn't. This line extends this way, this other line extends above it, and they're never going to crisscross, they're never going to intersect, they're not parallel, they're not overlapping, they're called skew. It's two lines that would not intersect, but they're also not parallel. This is a little bit more information than you need to know, but it's kind of interesting. It's just more vocabulary that eventually you're going to learn about. Speaking of vocabulary, the only vocab word for this lesson is, again, parallel lines. We've had this word a couple times now. So parallel lines are two lines in the same plane that do not intersect. They have the same slope. That is important. It's two lines with the same slope. Okay? That's how we're going to identify parallel lines. They have the same slope. And they don't intersect. So, what we'd like to be able to do here is very much like we did in the previous lesson. We are going to graph these lines. Now, right now, just looking at these two lines, there's nothing special going on. It's just, this bottom one here is already a slope-intercept form. We would graph it. This top one, we would have to solve for y first to make it slope-intercept form and graph it and find the solution. So let's do that now. The bottom one, I'm going to do in red. And I might as well just graph him now because he's already slope-intercept form. So my y-intercept is +1. My slope is down 3 over 2, down 3 over 2, down 3 over 2, dot. And in reverse, up 3 over 2, dot. And that's the line we got. Okay, the other one I'm going to do in blue. So let's highlight this. And in order to graph that, I must first solve for y. So I'm going to subtract 3x on both sides. I'm going to divide by 2 on both sides. This should hopefully be familiar to you by now. And that is what we got. So this is my -3 over 2x. This is where I got my +5. I took 10 divided by 2. Okay, if this is unfamiliar to you, you might want to check back some of the previous lessons. So I'm going to graph this. So I'm going to put my dot at the y-intercept of +5. 0, 1, 2, 3, 4, 5 is right here. And I'm going to move the way that my slope tells me to move. My slope is down 3 over 2. That was the same slope as the last one. down 3 over 2 dot, down 3 over 2 dot, and line. And so now we would ask ourselves, well, where do these two lines crisscross? Where do they intersect? They don't. They don't intersect. They don't crisscross. They are never going to be in the same place at the same time because these two lines are parallel. So if the two lines are parallel, if they don't intersect, that means there's no answer to this question. There's no place anywhere where both of these lines will have one point that makes both equations true. So since this problem doesn't really have an answer, we say this problem has, or the answer is, no solution. We've seen that phrase before. The problem doesn't have an answer. This equation, the system of equations, has no point that will make both equations true. There's no solution. Now, if you were doing this using a graphing calculator, come on, there it is. You still have to do this math. So I don't want you to think that the graphing calculator is going to do all the work for you. It's not. You still have to solve for y first. But what you do is under y equals here, you would just type in these two equations. Negative 3 over 2. And then, by the way, there is a fraction button. If you hit alpha y equals, boom, 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 this little doohickey comes up. So this first one here is a fraction. So I can hit negative 3, there we go, over 2 and get out of the fraction x. That's this button here, plus 5. And the other one is a fraction as well. Negative, oops. Yeah, I want that one. Negative 3 over 2 over x plus 1. So I have both of them here. I hit graph, and we wait a second. There's one line. There's the other line. And we can say right now, they don't intersect. There is no solution to this system of equations. So we're done. Okay. Very quickly, I'll talk about that later on. So let's get going. Next problem. I would like you to try this one. So I'd like you to go ahead and graph both of these lines in the space provided. Find the solution if you can. And then when you're ready to continue, hit play and we'll go through it together. All right, so let's do the first one in blue. So that is the line that crosses the y-axis at -2 because that's my y-intercept. My slope is -1/4, so I'm going to go down 1 over 4. Now, you look at my graph and go, I can't go over 4. I can go down 1, 1, 2, I can guess it's kind of here-ish somewhere. I mean, it's just a guess, but I like actually putting that dot there because what that allows me to do is see my line is going to be facing kind of like this. So now I know when I'm going the reverse, I'm going up 1 over 4 the wrong way, that it's going to work out. I can kind of see where it's going to go. And then up 1, 1, 2, 3, 4 the wrong way. And now I can get a nice straight line. You see how it still goes through my imaginary dot? It means I was a pretty good guesser out there. All right, so red equation, top equation. Solve for y. I'm going to subtract x on both sides. I'm going to get 4y equals -x minus 8. When I divide by 4 on both sides, these cancel out, and y equals a -1/4 x. That's -1x divided by 4, -1/4 x. And -8 divided by 4 is a -2. And you went to go and you graph that line, you go, hey, they intersected right there. And you move the way the slope tells you to move, and the slope has a dot there, and a dot there, and a dot there. And you realize that these two lines are exactly the same line. These two lines are overlapping. These two equations are identical to each other, which means their solution is everywhere. Every single point, well, everywhere on the line, like this point, excuse me, that point is not a solution. That point will not make these equations true, but this point will, and there, and there, and there, and there, and every single place on the line makes these equations true. There is an infinite number of answers. And that's what we're going to say. That's what this problem's answer is. We're just going to say there's an infinite number of answers. There's infinitely many. Infinite, ooh, I missed my ly. Looks like just a y. Infinitely many solutions. So I can't even just say what the solution is because there's too many of them. These lines are overlapping. We can say that. It's not what the answer is. It might help you understand. These lines have the same equation. It's the same line. So if it's an equation to one, it's always going to be equation to the other. Or I'm sorry, if it's a solution to one, it's always going to be a solution to the other. And if I'd use my graphing calculator and graph this, it's just going to look like one line. Okay, another one here for me. I'm already on red, so I'm going to graph this one in red. My y-intercept is positive 2. That's my y-intercept. My slope is positive 1/2. That is up 1 over 2. Up 1 over 2. Up 1 over 2. And in reverse. Boom. And boom. And boom. I have a nice pretty straight line. And there it is. Okay, so there's my first line. Second line, we're going to do in blue, and we're going to start by solving for y. So I'm going to subtract x to cancel out that positive x. If you might have thought about adding because this was a negative and you're thinking like it's x or x minus 2. No. This is a positive x. You subtract it away. This negative is attached to the 2. This is a negative 2y. So later on when we're getting rid of that 2, we have to get rid of the negative as well, which actually is in this very next step. So let's keep going. So we're here. Now, I need to get rid of this negative 2. Since it's being multiplied by y, I'm going to divide by negative 2 on both sides, and we get y equals a positive 1/2 x plus 2. And there's my equation. Now, I'm not even going to graph this one because I can see, look at these equations. Positive 1/2 x plus 2, positive 1/2 x plus 2. I can see they are the exact same equation. I know they're going to be the exact same line. I know they're going to have infinitely many solutions. And that's the answer to the question. If it helps you understand to say that they're overlapping, you can. But that is not the answer to the question. The answer is there's an infinite number of answers. I can't tell you one because there's too many. Letter D, go ahead and pause the video and do this one right now. When you're ready to continue, hit play, and we'll go through it together. All right, so we're going to graph this one first. That has a y-intercept of positive 4 and has a slope of 2 over 1. That is up 2 over 1, rise over run. And you might be going, I can't go up 2 over 1. Well, we'll take a good guess. I mean, up 1, up 2 over 1, kind of somewhere in there. But now I can see the line goes like this. I remember this problem specifically. A lot of students draw their line this way because they think, oh, I can't go up 2, so I just go down 2 and over 1 this way. That doesn't work. It should be over here, so your line's this way. So now when you do the reverse, down 2 over 1 the wrong way, it's here, and here, and here. Line. Okay, that was my blue line. Let's graph us our red line. So we're going to solve for y first. I'm going to add 6x to cancel out that minus. 3y equals 6x plus 6. Divide by that 3 to make the y by itself. And y equals 2x plus 2. I can see that these are not the exact same equation, so I'm going to keep going. Now, things I can notice. I do notice they have the same slope, but different y-intercepts. Having the same slope means they're going to be going in the same direction, but where they cross the y-axis is different. So check this out. I'm going to copy and paste and change it to red. I know it has the same slope. So now all I got to do is move this line with the correct y-intercept. So my y-intercept should be a positive 2. So I'm going to move this line till it crosses right there at positive 2. This is the same line, because look, up 2 over 1. Or over here, up 2 over 1, up 2 over 1. So this has the right slope. It has the right y-intercept of positive 2. These lines are parallel. That is not the solution to the problem, but it's a piece of evidence. They have the same slope. They're parallel. This set of lines, the set of equations, does not have a solution. They never crisscross. They never intersect, so there is no solution. That is the answer to the problem. There is no answer. There is no solution to this problem. So this page here is kind of a little table, a little graphic organizer, kind of help you get your thoughts in order on this lesson. So it says here, identify the number of solutions by graphing. So all we're interested in right now is just saying how many solutions are there? So when we have two lines that are intersecting, well, first off, it looks like, down the bottom, just draw a picture of two lines crisscrossing each other. It doesn't have to be anything fancy. They can crisscross anywhere you want. So they're crisscrossing right there. So what do we know about those lines? Well, we know that those lines have, get out of here. They have one solution. When they're intersecting, there is one answer. The answer is where those two lines crisscross right there. Intersecting lines have one solution. Intersecting lines, I hate that thing. Intersecting lines have different slopes. I'm going to zoom in because my writing is terrible. I don't think that helped my writing much, but they have different slopes. Always. They have to have different slopes. If they don't have different slopes, if the slopes are the same, the lines, well, will be one of the other two examples. Intersecting lines always have different slopes. And that's all we need to know about them. The slopes are different. They have one solution. The solution is where they intersect, as we've seen. Okay, parallel lines. I'm going to draw parallel lines. Using the magic of technology, I'm going to cheat because I'm going to just copy and paste this one. Copy, paste. Did it paste? There it is. So those two lines are parallel. Things I know about them. They have no solution. What else do I know about parallel lines? I know parallel lines have the same slope. That's what makes them kind of go in the same direction. But they have a different y-intercept. If they had the same y-intercept and the same slope, it would be the exact same equation, which is not parallel. If they had the same equation, it'd be the same line. That's the next one. So parallel lines, if you look at it, they have no solution. They do not intersect anywhere. This system of equations has no solution. Because these lines have the same slope, and they also have different y-intercepts. They're crossing the y-axis at different points, which means they do not intersect anywhere. The last of these is the overlapping lines. Overlapping lines, I don't know how you want to draw this one. It's a little hard with just a pencil. You could draw one like this and then draw like another one that's wiggly waggly. I don't know. Somehow show there's two lines. With the power of technology, I can make one of my lines wider. Style like this, and then I can draw like a smaller, skinnier blue line in between. You really can't do that on your paper and pencil though, but whatever. So overlapping lines. What do we know about them? Well, we know that overlapping lines have an infinite number of solutions. It's not one, it's not two, it's not none, it's lots of them, but it's not every point. So there's an infinite number of solutions. Infinitely many solutions. What else do we know about that? Well, for them to be the same line, sure, I can put that, same line, that means it's the same slope, it's the same, same y-intercept, it's the same equation. I mean, it's the same everything. That's why they're overlapping, is because it's the exact same line, just kind of over top of itself. Same slope, same y-intercept, same equation, same everything. It's the same line, okay? So why are we doing this? Well, first off, it's just a good kind of overview of what we learned in this lesson and kind of tying it in with the previous lesson. But also, there are some problems where they don't actually care what the answer is, or like they're not going to say, find the solution. It might be something more like this. Determine whether the linear system has one solution, no solution, or infinitely many. You do not need to find the solution. So all we care about in this problem is how many answers do they have? How many solutions does it have? One, none, or infinitely many. And the way we can do that is if we take each of these equations and make it y equals, we can look at their slopes and their intercepts, and using this information right here, slopes, intercepts, we can determine how many solutions it has. So let's do that. I'm going to take this first one here, and I'm going to solve for y. Actually, I lied. I'm going to do this bottom equation first, just because I can work in this space right here, and then I'll just move him further down. So the bottom equation solve for y, I'm going to add 10x first to cancel out that minus 10x. I have negative 2y equals 10x plus 4. I'm going to divide by negative 2 to cancel out that times by negative 2, and y equals negative 5x minus 2. So there is the one equation. I'm going to change to red so you can tell the problems apart. Ooh, a little further down. And now I'm going to do the second equation. So just copying it down first. All right, so now when I solve for y here, I'm going to subtract 5x on both sides to cancel out the positive 5x. And y equals negative 5x minus 2. All right, so now we've taken both equations and solved for y. Look at them. Y equals negative 5x minus 2. Y equals negative 5x minus 2. It's the exact same equation. Same slope, same intercept, same everything. So this system of equation has infinitely many solutions. I know that because it's the same line. They will be overlapping when I graph them. Letter B. This bottom equation is actually already done. It's already slope-intercept form, so I don't have to do a darn thing to it. So I'm just going to go ahead and I'm going to jump to the top equation, and I'll move them down here. So 5x plus 3y equals 6. I'm going to subtract 5x on both sides to cancel out that positive 5x. 3y equals negative 5x plus 6. I'm going to divide by 3 on both sides to cancel out that multiply by 3. And y equals negative 5/3 x plus 2. So now that's slope-intercept form. So let's look at these two equations. I have a y equals negative 3/5 x plus 2 and y equals negative 5/3 x plus 2. So are these parallel, overlapping, or intersecting? I like to look at the slope first. Are my slopes the same? No, they're similar. -3/5, -5/3. It's kind of the same, but it's not the same. Which means these lines will intersect. They will crisscross somewhere. And I can prove that to you. Where's my other graphing calculator? So I'm going to, if I can, clear and clear, I'm going to quickly show what this would look like. So if you've got a graphing calculator, you can follow along with me. I'm going to type in my fraction of -3/5x plus 2. And my other graph is alpha y equals, fraction guy, -5/3x plus 2. All right, I hit graph. There's the one line, there's the other line, and they're crisscrossing at one point. Now, if we wanted to know what the actual solution is, we could use the graphing calculator for that. We have on the graphing calculator this calc feature. You see it above here, above this trace. It's in blue. It says calc. Check this out. If we hit second trace, this calculate feature, we want to calculate where the lines intersect, number 5. And it's asking right now the first curve. So I'm sliding away from the y axis just so you can see. So it has this little cursor dude. And you can slide left and right and up and down. And it changes from one line to the other. If you hit up, like it's this line, down, I hit this line, and left and right kind of moves it sideways. So it's just asking, what's the first line? Well, this is my first line. Where's the second line? Well, just click it on the second line. And then it asks for a guess. It's trying to get you to move your cursor close to where the lines crisscross, because there are times where the lines may crisscross at multiple places. It's curious which one you're talking about. Well, here there's only one. So I'm just going to get it roundabout and hit enter. And here's the answer. This is actually the solution to the system of equations. It is when the point 0, 2. I almost wrote y. It's when your x value is 0, when your y value is 2, is where these lines crisscross. And I'll be honest, we could have guessed that because they both have the same y-intercept, but different slope. So they're crossing at the y-intercept. But that's how you can use your graphing calculator to kind of help you with this process. Also, depending on what type of assignment you're doing, you could use something like Desmos to, once you've solved them both for y, you could use Desmos to graph the equations to kind of see what they look like as well. Letter C. Go ahead and I'd like you to see what you can come up with. See if you can solve both equations for y. Tell me, how many solutions does it have? You don't need to find the answer. Oh, I forgot to say, this problem has one solution. I didn't actually have to find the answer. That was bonus. This problem has one solution. My bad. All right, back to letter C. Pause the video, find how many solutions it has, and when you're ready, continue, hit play, and we'll go through it together. All right, so top one is already solved for y. Don't have to do a darn thing. Yay us. Bottom one is not. So I'm going to add 6x to both sides. That's a 6. Add 6x to the other side. I have 3y equals 6x minus 4. I'm then going to divide by 3 to cancel out that, multiply by 3. And I get y equals 2x minus 4/3. I'm going to leave it as a fraction. I could divide and change it to a decimal, but it's fine. All right, so based off those two equations, what do we have going on? Their slopes are the same. Let me highlight slopes. Nice, beautiful pink color. So their slopes are the same. That doesn't help us. I mean, well, I lied. It does help us. If the slopes are the same, that means they're either parallel lines or they're overlapping lines. There's my overlapping. So it's one of those two. And the way we determine which one it is we look at their y-intercepts. If the y-intercepts are the same, would mean it's the same line. If the y-intercepts are different, it means they're different lines. Here, the y-intercepts are different. These are different lines. These are parallel lines. This problem has no solution. If we would graph both of these equations on our calculator or in Desmos, we would see that they are parallel and they have no solution. Okay, summary. How do you determine whether a linear system has one solution, no solution, or infinitely many solutions? Do a little summary of the lesson if you could, please. How do you figure this out? What things do you look at and how do you make that determination? Go ahead and pause the video and give yourself a little summary. When you're ready to continue, hit play and we'll go through it together. All right, so the things you should look at. First, you look at, well, first you solve for y. Solve for y. You make your equations y equals. That way, you can do your next step, which is you look at the slope. If the slope is the same, oh, let me back that up. If the slope is different, then you know you have one solution. If the slope is the same, then you have to go a little bit farther. Then you do your last step, which is you look at your y-intercept. If the y-intercepts are different, if you have the same slope but a different intercept, it means these two lines are overlapping and you have, no, I'm sorry, they're not same slope and different y-intercepts. It means these lines are parallel and you have no solution. If they have the same slope and the same y-intercept, it means they're overlapping and there's infinitely many. Trying to squeeze it in there. All right. So that's that is a little summary. I personally like this chart a lot better. I think this is a better job of describing it, but this is essentially what you were kind of describing in words. Okay. So thank you much for joining me on this lesson on the special types of linear systems. In the next lesson, we move past graphing. So until the next lesson, thank you so much for watching. Toodles.